This RU project aims to explore robotic sensing for energy smart and privacy preserving through condition monitoring and surveillance. The RU students that worked on this project are Myra, me, Hanumath, and Sayan. The graduate students who assisted are Yujing and Zihao under the guidance of our advisor, Dr. Chen Khan. As robotic sensing becomes more popular, its integration into manufacturing systems becomes more prevalent due to its cost-effective and flexible monitoring. Along with robotic sensing, additive manufacturing such as 3D printing is also on the rise of popularity. However, there are inconsistencies associated with this form of process. Robotic sensing presents a lack of strategies in power consumption and information privacy preservation. The novelty in this project aims to integrate low power consumption sensor using autonomous car and triple axis accelerometer that sends data to a cloud server in efforts to preserve data from being compromised.
During the printing process, sensor positioned at the top and bottom will capture images of the signal plots and send them to a computer. Using convolutional neural network, the system will be trained to recognize whether the input represents normal, abnormal, or severely abnormal vibration. If an abnormal or severely abnormal vibration are detected, the computer will alert an autonomous vehicle to inspect the 3D printer visually. The vehicle will capture images, which we will then classify as normal or abnormal using random forest classification. And finally, we will evaluate the model accuracy, sensitivity, and specificity.
Today, I want to take you through a journey into the heart of our project, focusing on the AWS Deep Racer, the Jetson Nano, and the intricate experimental setup that serves as the foundation of our research. In this project, we've harnessed the AWS Racer's autonomous capabilities alongside the NVIDIA Jetson Nano's powerful computing to revolutionize real-time monitoring of 3D printers. Our experimental setup involves deploying the Deep Racer for on-site data collection, with the Jetson Nano processing this data through advanced machine learning algorithms for immediate anomaly detection. This synergy not only accelerates the identification of printing errors, but also significantly reduces unnecessary data processing, leading to more efficient monitoring operations.
A convolutional neural network takes in signal data collected layer by layer as input. It then processes this data through multiple stages. First, it applies 64 filters, followed by an RELU activation to enhance pattern recognition. Next, max pooling layer condenses information. After that, another set of processing occurs with 128 filter and RELU activation. The data then goes to fully connected layers with 4096 neurons each. Finally, the network output uses sigmoid activation to determine the probability of the input being defective.
The random forest classifier method uses the features extracted from images to train and learn patterns in pixel values associated with different cases. It processes a dataset of images, first converting them to grayscale and resizing them to a uniform size for consistency. After dividing the dataset into training and test subsets, the script trains the random forest classifier on the training data, utilizing multiple decision trees to capture different patterns. And 80% of the data that we have gathered is used for training and 20% for testing. The classifier then predicts the categories of test images. The performance of the classifier is evaluated by calculating accuracy, sensitivity, and specificity, providing measures of its classification effectiveness. And the accuracy that we are getting is 95% for this algorithm. In conclusion, our innovative approach combines the strengths of autonomous navigation and edge computing to offer a pioneering solution in industrial monitoring. This project not only demonstrates the feasibility of using such technologies in practical applications, but also sets the stage for future advancements in automated and intelligent monitoring systems.